We're back with binary search. Um, I somebody told I was talking to a friend and they said that they didn't like the binary search problem because the iterative solution can be kind of confusing because it's very easy to get off by one errors due to all the array indexing and the halving and the whatnot. Um, uh, but actually, I think this is a very simple problem using recursion. Um, and I'll show how you can leverage the recursive solution to generate the iterative solution rather cleanly. I haven't done this problem in probably like over a year or 2 years or 3 years. Because recursion is just such a powerful pattern, um, I think I can do this problem fairly quickly. So it's like 6:30 on my side right now. So I'm just gonna crack into it and show you, give you guys an idea of how I think about the problem. Okay. So we're gonna define f of x in array. Again, I use the shorthand f because it's such a short. It makes it easier to saves me typing essentially. I'm using like a short one-letter function name. Okay. Oops. Begin. Okay. So I'm gonna let's codify g of x r return f of x r, or actually we'll just use default arguments here. Oops, actually I can't do that. F of x r 0, and then we'll do lane. Yeah, so ij will be the I will be the start index and j will be the end index, unless j will be the one pass element will be the sentinel value. It'll be the length of the array. Okay, so let's dive into this. Let's first just start off with our base cases. If one, so basically I and j are sort of our they determine the slice that we're going to use. Um, so we can actually just call it like slice. Let's just call it like our sub array is equal to rij. Okay, if lane sub is equal to 0, then we will return -1, right? Because there's no way x is an empty array. If lane sub equal 1, then we return if if sub 0 equal x, return I, else return -1. Okay. So if x is in the subarray, then the subarray of length 1, then we just return I. Okay. So binary search, I'm sure you all know, is you look at the middle element. So in this case, because we're doing binary, because it's like we want the middle element between our subarray of ij, then what we really need is like median mid is equal to I plus j over 2. And the way that Python does division with integers is, let's say I is 0 and then j is n, or j is 1, then when you do the division, j will be 1, will be 0, because it's 1 over 2. Okay. If the length of the array is 2, and you do the division, then you'll return 1 because it's 2 over 2. Okay, so let's go through this, and like the median value of our subarray is going to be equal to, you know, we don't actually need this. The subarray is kind of useful, but the median is actually just going to be yeah, I guess the median is just going to be actually this. Okay, and then if x is equal to mid, we're just going to return the index. Otherwise, we're going to return f of x array, and then else if x is greater than mid, then we want to look in the upper half, so that'll be mid plus 1 j. Okay, else we want to return f of x are I mid minus 1. So let's just walk through an example really quick. So like, let's say we have 1, 3, 5, okay, and we're looking for the element 1. Let's do something more complicated, like 1, 3, 5, 6, 8, 9, 15. Okay, let's say we're looking for the element 9. Okay, in this little array here. All right. Then we look through the initial ij indices are going to be 0, and then we have a length of 6. Okay, so these are our ij indices, and then mid is going to be equal to 3, and so our median is going to be equal to 6. All right, cool. Okay, so 6 is less than the median. My bad. Oh, sorry, 9 is greater than the median, so we look at the array 9, 15. Okay. So then our ij indices are going to be 4 and 6 again. Okay. Oh, actually, that reminds me, this should actually be mid, because mid minus 1, because it should be mid instead of mid minus 1, because the jth index is 1 past the element that you're looking for. Yeah. So we look here, and we're like, okay, mid is equal to 5, because we're taking the average of 4 and 6. Okay, and then the median is equal to 15. All right, and then what we end up with is so 9 is less than the median, so then what we're looking at is the slice of 4, 5, which gives us a mid of 4, which is actually an array of size 1, which is just 9. So return 4. Okay, so we should return 4. Let's just double check this. I might actually, like, let's just see what will happen if we do this. Okay, oops. Actually, I think I'm on Python 2, so I don't need this. Okay, Python binary search. Oops. And we don't need, I guess we do need this. Hold on. Okay. And then I actually defined this function g. 4. Okay, cool. So it works. All right. So unfortunately, yeah, like I still had some off by one errors coding this up, unfortunately, just because of um, the array slicing that I was using. Um, that's kind of like, man, that's like unfortunate. Man, I really wish I had figured out a better way to do that. But anyways, let's just keep moving forward, plan forward, as we do in these types of questions. And you'll see that, I mean, this is tail recursive, so it's actually still pretty good. We actually didn't need this. We can remove this reference to the subarray by saying that, if I is equal, if I is greater than equal to j, um, then the slice will be, it reduces because if I is greater than equal to j, then the sliced array, the sliced subarray will have length 0. If I plus 1 equal j, then we have a subarray of length 1. Um, and in fact, we actually don't need this because I don't think we actually need this because of um, um, yeah, I don't think we actually need this in fact because the median will always be the lower of the, if in the case that I plus 1 is equal to j, the middle index will actually be reduced to I, and then we'll do a check, and if it fails, then we actually go here or here, in which case no, actually we do need this. Otherwise we're going to infinitely recurse. I guess we do need this. We do need this, unfortunately, because we're going to recurse infinitely without it. Okay, that's a bummer. Um, yeah, let's see. Yeah, uh, I'm not a super big fan of this, to be honest. If R and we can get rid of the 0, get rid of the use of sub by just using the array and indexing I, and returning -1. And yeah, so you can see that we don't use any additional memory except for like it's 01 additional memory. Um, and basically we're just doing a search on the left and right. Honestly, I'm not super pleased with how dirty this is because there is a bunch of like random +1 and -1. Um, God. Okay, let's try this to make this a little bit better. So instead, now we're gonna say, eh, you know what? This is fine. This is fine. Okay, so let's just see how we would convert this to an iterative method. Um, while so we have this function here, right? And so we're just going to slowly reduce these first two cases while I is less than equal j less than j minus 1. All right. Um, and we'll just do like fill in. And then our base cases are actually still pretty much the same, right? So if I is greater than equal to j minus 1, greater than equal to j, we're going to return -1. If I plus 1 is equal to j, then we return, we either return I or return -1. And then we just need to move the rest of this code here into this while loop. Um, And instead of doing a recursive call here, we just set I is equal to mid plus 1, and then j stays the same. Otherwise, j is equal to mid. And let's test that that works. Yeah, and it does. Okay, so that was actually a pretty easy way to go from the recursive solution to the iterative solution. I actually still prefer the recursive solution to the iterative solution just because when uh, I mean, they're basically fairly similar, but the recursive solution is still, I think, it's still less work to think about recursing rather than thinking about like this for loop or this while loop condition. And I do like the fact that we can kind of just stack the in the recursive function, we think of the base case first, and that's the first thing we check. Whereas in the recursive solution, we have to figure out like the loop first, line 16 through 24, before we can apply our base case checks. So that's the like very easy version of binary search. And I'll probably do a harder one in the next video. All right, cheers, bye.